Very true. All right. Well, we are here to round things out with Chapter 12, Generated Behaviors, and this one is the hopeful vision of the future chapter. When I finished this chapter, I was on quite a high, and it's like, man, I want to see this vision come to life. And then looking back through it, I'm like, man, this guy's a nut job. But he must have gone off the rails at some point. But no, just
I don't know that those are mutually exclusive.
no, probably not. But kind of starting with the idea of interest. So this was basically the idea of interest is that we can use the shape of the queries themselves to tell us what somebody is interested in, and from there we can derive how to satisfy that interest. When we're talking about pub sub, it's up to the subscriber to actively subscribe to the messages that they want. So they have to know what messages they need to pick up. They need to know where to pick them up, and they need to know what to do with them. So that's three separate dimensions of really the same thing. It's kind of like you've got 3 degrees of freedom when there really should only be one. So if you could just simply express, hey, here's the need, here's a query, satisfy this need, give me the results, then wouldn't it be great if the system could figure out who needs to tell you about that, and what messages are going to be necessary for them to tell you that. And now that you've got the query, what you do with it is up to you. So that's really kind of getting back to kind of what I opened the book with, in the fact that building these distributed systems is really hard, and humans build them, and humans make mistakes. So wouldn't it be wonderful if the humans could interact with, have a conversation with a machine that was running some rules, kind of like the way that we have conversations with our compilers as we get something to work, and it's that the compiler is running some rules for us and making some inferences, and so we can discover what those inferences are as we're writing the code, and then write a bit more code to make sure that we're working within that rule set. It should be the same with distributed systems, just at a larger scale, and that'll take a lot of the opportunity for error out of the hands of the human, and put it into the runtime and the languages, so that they can have that conversation with us. And that's really the point of computing interest rather than subscribing to messages.
Michael, but that would mean for a mobile application that I would have to express interest in all the things that I need up front.
Mm-hmm.
Because I might, at a certain moment, I might be offline. At that time, when I'm offline, I might go to another screen, another window. And behind that window are other facts that I need. So all the time, my application has to subscribe or has to communicate all of my queries to the server. Is that correct?
Yeah. In fact, let's look at an example. Kind of going back to the Pluralsight course where I talked about Rover Mob and the patterns for doing this in mobile applications. So if you in that example, it was a service worker who was picking up tickets, and a ticket was assigned to him, and then because of that, he was interested in facts about the place,
incident.
The incident, and
Mm-hmm.
so where he's going to go to service that incident, and what the history of it. So So at the very beginning, he was interested in what are my assignments, and then once he finds that he has an assignment, then now he becomes interested in facts about that assignment. So on the one hand, so to do that with a very explicit subscribe type of an action, he first subscribed to his own technician fact, and then found the successors there, and then running a quick query to find their predecessors, subscribe to their predecessors in order to find their facts. If you were to express that all at once in a pipeline, then you would end up with starting with technician, do a successor step, and then from each of those assignments do a predecessor step, and then from each of those incidents do the successors. So you would get that zigzag pattern in your pipeline. And so now if you were to give that pipeline to the server, now it's not up to the mobile application to know that this technician has been assigned an incident. The server would be able to see that, and it would run the query inverse, and it would say, okay, because I can see this assignment, even if the mobile application doesn't know about it yet, I know that they're interested in this incident. So the server will start pushing it down.
Yeah, but imagine, so that was his screen where he got his assignments. But he could also have another screen where he could, for example, go into the stock, the stock of the spare parts available at the company site. That's a completely different window. And behind that window, there is another query. Because he needs other facts. He needs an overview of all the spare parts in stock. But so while he's offline, he might switch between these two windows. He might close his incident and visit window, and he might go into the open the spare parts window. But since he needs to have all the spare part facts already on his device, that means that all the time both queries should have been sent to the server. Is that correct?
Yes. So the application shouldn't just send the query to the server when the user navigates. It should gather up, and basically the application, the mobile app, should really just have one pipeline. That is, this is everything that this application is interested in. They start it up on their device. Oh, I've got a connection. Hey, server, I'm here, and this is what I'm interested in. And then, so even if they haven't navigated to that screen yet, the server says, oh, I know that you're going to be interested in this because I can see, this zigzag shape in the data structure. So start pumping that down to you. And then when they go offline, they can navigate around and the data will be there at that time.
What about adding some kind of filtering mechanism on the server? So, let's say you have periodicity to this. One of the apps that I built a few years ago was a labor tracking application, and you're out in the field and they have handheld devices that are, imagine that, partially connected. And sometimes
very familiar concept. I mean, this you
never know which
example.
one you're going to have. yeah, exactly. And so in this case, however, every day there were new work items or work orders for them to accomplish. And so, really all that needed to happen was that if there was anything still on the device from a previous day that needed to get transmitted, you didn't want to pull that off the device yet. But once it had been, once you were confident that it had been, and there, obviously there's ways you can tell that, once it's been shipped over. But then it's now just all their interest should be is the current period, but the device isn't deciding that. It was based on the user and the work orders that user was assigned. And of course, more than one user could be assigned the same one for overlap or whatever purposes, right? But anyway, so I'm guessing that's allowable here as well, is you can filter that pipeline a little bit more on the immutable runtime server side of things.
The ideal way to do that is to use the period pattern.
Right.
So your pipeline doesn't start just with the technician fact, but it would start with a technician this week fact. So
That's right.
So yeah, they're.
But how would you
based on
choose the
those,
current period, I guess, is what I'm wondering. Would you need a convention where the app and the server decide what current means, or would you add a property to the period that says current, and then you could also have another, one-off, not a property, but a fact, and then you could have no longer current fact, and now this is current, or, how would you?
Yeah, the way that that I typically do that is that each node decides for itself when the clock is ticking forward.
Okay.
And I used to refer to that as the train switch pattern. Although when you actually visualize that, you get a really nightmare. But the idea that you've got a whole bunch of cars going down a track, and then you just switch the track, and now it's suddenly going down the other one. So assume that that's an atomic operation, and you can't get a car that's some wheels on this track and some on that track and going sideways. But now the producer of those things doesn't care which side it goes on. So it's like, hey, here's a whole bunch of stuff coming at you, and you're like, okay, I'm receiving stuff, and now I'm going to switch the track. Let things settle down, and now I can observe what it is that I received, and now I know that it's
and that makes sense, because I guess in this case we're not really worried about the wrong period being a security problem. It's of course you want to authorize that pipeline for that user and only give that user the facts that they're authorized to see, that they've been granted or whatever, right? That they should see. Yeah, that makes sense. So I guess in essence what you would do is you would have to have an agreement, sort of, let's say you had a web app and a mobile app. You'd need to have some kind of logic that would say, given some, whatever, UTC time range or something like that, this is how we define the period. And if your clock is off on your device, then you're going to resolve to the wrong period, but, right?
And if you do this one extra thing, that'll be okay. As a consumer, you are interested in more than one period. So you
sure, and you mentioned that in the book, right? Don't just look at the current. You might want the previous, maybe even the previous two. Plus, my mind is still just in pain from the years when we didn't have clocks that were easily synchronizable. Writing Windows mobile apps, and the world has definitely changed. So you're far more likely now to have a clock that's synced with a NIST atomic clock, which makes things a lot easier in this regard. But I remember
I wouldn't rely on that.
No, you can't rely on it. But you're far more likely to be, close. Whereas we could be off by months with those old cruddy Windows devices, mobile devices. So
yeah. The clock's being off of that much, that would probably cause some issues. But
and then you probably need to do what I'm describing, right? You'd have to contain that volatility now on the server side. But I appreciate what you're saying about you're pushing me back towards. Don't make it localized, keep it distributed, keep it autonomous, let the nodes decide. So that's good.
Yeah, so the server is interested in all periods. That way, if a mobile app is offline for a long time and then it comes back on and it's like, oh, I've got some facts that are related to these things that are 5 months old, then it can still go ahead and publish those facts, and the server will accept them.
Yeah, and if that was like time card information, you dang well better, you probably wouldn't have waited months, because employees probably would have complained by now. But even still, you still owe those people that money for that time. So that needs to flow through.
Yeah, and there should be now some new facts that you can now compare those, and these happened concurrently, where I paid you because you complained, but I didn't see the invoice, and now here's the invoice, and so I can reconcile those. So there's always there's bookkeeping. Somebody's gotta do that. But if the data structure shows you that these were concurrent, then at least you can use that to help you out.
That's great. You can still pay. Like, let's say the device battery died and you're having trouble rebooting it, but you have to pay them. So you pay them and you say, if we can't ever reconnect this thing, we did the best we could. If we can reconcile down to the penny, and maybe you owe us because we overpaid you, or maybe we owe you, or whatever. Yeah, no, that's really good.
Yep. So the interest set usually ends up being smaller on the mobile device and larger on the server, and each application gets to specify what it's interested in by giving those pipelines. And so, yeah, an important part of a pipeline is it has a starting point. And so that starting point allows you to move that pipeline from one period to the next. And in fact, say, I'm interested in this pipeline from these 3 starting points. And so now you've got 3 periods coming down.
Yeah.
Cool.
And what are the consequences for the performance of the server? Because if you have, let's say, 1,000 mobile clients, and the server has to calculate the query inverses for every mobile client, it's going to be quite a load.
Yeah. So the pattern that I like to use to implement an ephemeral type of a client, like a mobile client or a progressive web app, versus a server-to-server, more permanent connection, is for the ephemeral client, the node itself keeps track of all of the bookkeeping information. So it's got the bookmark. It knows that I've received from this point, and so when it connects is when it says, I'm interested in this pipeline from this starting point, and here's the bookmark from the last time that we spoke. And now the server has to perform that query. It has to to do all the figuring out which facts that client is interested in, and filter based on the bookmark and could be down to which fact they had seen previously, just hash by hash. But then it responds to that client, and then it forgets about that client. Now the client updates its own bookmark, and then the next time it communicates, it will say, "Hey, I'm interested in this exact same pipeline as said before."
So the server is not remembering the query, which it can use as an inverse query for notification.
And not for the ephemeral type of clients. So if we wanted to do a push notification to a mobile application, now it's that mobile application has just become more permanent, but it's still not ultimately permanent like server to server. Well, even that's not ultimately permanent. Even servers go away. Topology changes. Imagine that. But there it can last longer. So the server can cache that pipeline and those starting points for that particular client, as well as the means by which it's going to send it notifications. So, like if you're using iOS, the mobile app will talk to Apple and get a URL, and then it'll give that URL to the server and say, okay, when you've got something, tell Apple about it, and they'll ping me. So it's like, okay, I'm going to keep that URL. I'm going to keep your pipeline and your starting points, and that is going to be in a cache that lasts for a certain period of time. So anything that comes in, I run the inverse. I see if it is supposed to go to you, and if so, I'll send you that push notification. And then, after 10 days or whatever, I'll stop doing that, because presumably when I send you a push notification, you should be getting back to me as soon as you can. And
then we reset the counter, and the period starts again.
Yep.
It has some. There's some correlation to, I mentioned before that I wish I read this book, 7 years ago. Dang you, Michael, for not writing it back then and telling me about it. So what we did is we had an event-sourced model, and then we made projections of that event-sourced model. And one of the things we did is we created something that we called feeds. And the idea, so you're going to see similarities with things like interest and projections and things like this. But the idea then was certain feeds, and by the way, what was in a feed just went over the wire. It was just JSON over the wire. There wasn't like a different endpoint or anything like that. So what a mobile device would do is first it would register its presence and say, here I am. Right? So we had a registration manager. It's like, wake up. Oh, here's a mobile device. They're authenticated. They're good. And then the server would determine what are the feeds that that client should be subscribed to. And it would basically hand it a list of feed IDs and say, these are the things you should subscribe to. And here's the starting index number for that feed. The client would then just background process. It would start pulling each feed and also in parallel, right? We could do like multiple connections. I think we did 2. So it'd start pulling data for each feed until it got to the last marker that, I'm sorry, it wouldn't give it the starting marker, it would give the ending marker for each feed, okay?
Right.
And then if there was a change on the server related to one of those feeds, all the server had to know was, well, who's subscribed to these feeds? And then all it would do is just send a push notification saying, recheck your feeds. And it would take its current set of feed markers, right? I've got 10 feeds and they're all at version 100. And it would send just that to the server. And then the server would say, this one feed right here has one new message and I'm going to push it up to you. So really similar to what we're talking about here. But also not, right? Like there's some key differences. But part of the reason I wanted to bring that up as well is I envision places. One of the powers of this was multiple mobile devices for different people could be reading data from the same feeds. So sometimes there were client-specific feeds. By client, I mean the user, right? Sometimes there were user specific feeds. But other times, and also device, but the device would keep track of its own bookmarks, right? And we didn't have different nodes, although now it's like, okay, well, we could have and we should have. But the server could then say, oh, these 3, labor, what are they, timekeepers. These 3 timekeepers are all going to look at this feed, this feed, this feed. And then these 2 are going to look at this shared one. And then these, right? And we could sort of block it out that way. Is similar stuff possible here where you could have like a shared pipeline to kind of deal with Jan's concern about having a different feed for each individual user?
Yeah, absolutely. And so the incident concept. So there would be one feed for the technician, but that wouldn't include all of his incidents. It would just include that technician's assignments. But then a different feed for each incident, and then like you were saying before, it could be that multiple technicians are assigned to the same incident, and so they would each subscribe to that one incident, and that way now the server isn't keeping keeping track of all the different mobile devices that are out there. Instead, it's just keeping track of all the different incidents there are and all the different technicians there are. It's keeping track of stuff that's in the data model, not stuff that's in the topology.
That makes sense. And I think, like along those lines too, I think you could make some of these things explicit in the model. So let's say you have periodicity to your incidents. That's one thing you can add. Let's say you want to add geographic regions. And then, you might say, well, today you're assigned to incidents for this week in this geographic zone. But if suddenly you need them to drive across town, all right, we're now going to also assign you to this geographic zone, right? So now you've got 5 of your technicians are in this zone, 5 are in this zone, but you actually need this person to be in both. And then they're going to see the feeds for this period for this zone and this period for this zone, but everybody's getting the same data for each zone for that period.
Yeah.
It's just one person's getting it all and everybody else is just getting the ones for that, right?
I like
an example.
I like that idea because that actually even brings in some information from the device itself. So it could just be that device's GPS says, well, now I'm actually in this position, in this place. So if I can talk to the server, I'll say, hey, I've got a new starting point for those queries.
Yeah. Oh my gosh, man, that would have been so helpful because we had a labor contractor that had 40,000 employees, and we had to download. This is insane, but they wanted us to download every single one into the device. So that in case somebody happened to show up 300 miles away from where they were supposed to be, they could still scan them offline. Now, of course, in hindsight, what you do is you create a QR code, right, with enough user information embedded and maybe an HMAC to validate it, and then you scan that, and that way you can do that offline, which we ended up doing, by the way. But just 40,000 employees just because they might show up anywhere is definitely not a good solution.
Yeah, and this is going down a bit of a tangent, but I've actually thought about if somebody has tessellated the planet so that you can say, okay, I am in a particular triangle, on the surface of the Earth that has a unique identifier, and I can easily see that it's adjacent to these other triangles. So then I could do a location-based query that is still it's not floating point. It's not that long, but it's discrete. And then I could have facts that represent those particular triangles, and now I can subscribe to
that has
a region
to have
of
been
them.
done.
Yeah, I'm sure. But,
and then in each triangle, you can break that down into triangles down to a certain level. Ooh, interesting.
Yeah, sure.
Yeah, I
certainly,
like that.
There's some organization that has that as an ISO standard somewhere. I just haven't found it.
It makes sense, and then you could do proximity mapping, and only load the stuff that you need. And oh man, I like that idea a lot.
Yeah. Anyway, that is a challenge, but an interesting, or a tangent, but an interesting one. So, the kind of taking so a lot of those optimizations that we just talked about are things that you could do by hand. The challenge is, can you figure out how to take a pipeline description and have the system figure out those optimizations for you? And I think the answer is yes. I would say that that's not something that I proved in chapter 12, but because actually chapter 12 is pretty light on the proofs. It's like, hey, let's try to build this amazing world. But if you think back to in chapter 11, talking about how you find pivots and then those pivots inform where you create topics. That's basically the analysis that you're doing, and you end up with the entire cone. All of the successors are in that topic. So if you were to write a pipeline and the pipeline queried down into those successors, that's being very explicit about which successors you're interested in. But it's possible that you might have a version of the mobile app that like it's an older version. It doesn't have all of the successors, but now new version, new feature, new successor facts, and so it's got a deeper pipeline. So in order to do that optimization and put everything into the right feed, you would have to somehow recognize that this pipeline is a subset of that one, and it can go ahead and piggyback on the same feed, and then we'll just end up sending them facts that they don't know how to handle yet and don't care about. So they can go ahead and store them so that when you upgrade the software on that device, the information's there, but they wouldn't know what to do with them yet. So I think all that is possible.
You might even be able to use that for feature flagging, meaning if you don't have any facts of this type, you don't see this feature. And then suddenly, if you start getting, again, this would be probably the server doing some filtering on what you get and don't get, right? But if suddenly, pop, if the app doesn't know about that, it does nothing with it. It just keeps it, right? And eventually might purge it if a period moves or shifts or something like that. And if it does know what to do with it, it might just turn on this capability now that they've now been clearly given because this fact showed up. That could be interesting. In fact, that way you could even simplify the application, because maybe in a certain period you just don't need a particular feature turned on because you don't have a particular thing assigned to you or a particular error. So now the application is actually dynamically changing the available functionality based on the actual work you have to do. Now, that could be fun.
Yeah. Yeah, and that also allows you to do like a slow rollout of the application. So it's like, okay, I'm going to push bits to everybody, but we're just not going to light it up until, okay, now we're pretty confident in those, or we can light it up in test scenarios and they can see the new features. But then, yep, all right, it's good. So now those facts start trickling down, and oh, look at that new feature. I don't remember getting an update. It's because you already had it.
Yeah, and you could push out those updates to everybody, and they don't have a way to turn them on. And you can battle test them, and then the beauty is when you want to roll that out live, if everybody's got, the evergreen updates already from the App Store, facts just start flowing, app starts ooh. Now this is chapter 13 now. Now we're really dreaming.
Yeah.
And then the bugs are coming in.
The what?
The bugs are coming in. Support calls.
Oh, the bugs, yeah. I thought you said the bucks are coming in. I was getting excited about that, but okay. Yeah, well, you have to deal with the support. Yeah, and I think that's part of what's going to it would be necessary to help this to catch on. It has to be practical. People have to be able to apply it. And so coming out of chapter 10 and 11, those are really practical. And you can just analyze your model historically, and then you can take a look at your SQL database and say, well, I can refactor things this way, and now this becomes an immutable database, and I can start using foreign keys in this way, and then start to build some of these protocols by hand, and start to. So when you have this question of that seems rather suboptimal that I'm sending this entire pipeline to the server every time. Can't the server just do something like, keep track of these feeds and share the feeds among different people? Absolutely, you can. So now you're just doing the math yourself. You're just analyzing and saying, well, there's the pivot. I'll put every successor in that feed, whether the app asks for it or not. And so if if somebody stops at chapter 11 and is able to build based on the analysis of historical modeling, that's fine. But that's going to take a very dedicated expert to do that. Basically, that's the description of my career. So it's like, I've been really dedicated to this idea. So every time somebody needs me to build an application, it's like, okay, we're going to grab our SQL database, and we're going to grab ASP.NET, and we're going to grab Node, and we're going to start using the tools that people are used to, but now just in this way. And then when people look at the database and say, well, why so many tables? Say, because. But then there's correspondence, and there's Janaga and the immutable runtimes that then really start to build these ideas in and start to do some of the work on your behalf. And I've found that when I'm able to use one of those, which I haven't really been able to use one on a client application. It's all been things for my company itself, or things for myself. But I find that I'm just incredibly productive because I'm not thinking about doing these optimizations by hand. I myself am okay with the with some of the trade-offs and the consequences. I'm okay with the fact that if you were to take a static data store and a historical data store and compare their sizes, the historical data store is probably going to be about 2.5 times bigger than the static one. Just on average, this is just an observation of how often things change. So if you if you insert a record in a static data store, you're probably going to come back and update that record over its lifetime, 2 to 3 times. Some a lot more, some not at all, but that's kind of what it averages out to. And I found that true deletion in a static data store hardly ever happens, but people love that it's an option. So yeah, I think one of the barriers to entry is that initial concern, like, oh, this is going to grow unbounded. Well, it's going to be about 2.5 times bigger. I'm okay with that. You don't have to be okay with that. You can make your own decisions. You are doing your own optimization. But then when we get into an immutable runtime, that starts to take that optimization capability away from you, and that's deliberate because you can make mistakes. But then now it becomes more incumbent that the author of the runtime is being as responsible as possible with your hardware and your user's hardware.
And again, it all depends on your actual use case, right? Like a lot of this stuff is going to be esoteric until you actually are implemented in the real world. It's entirely possible, I would imagine, that you could archive an entire set of facts and resync every node, depending on the nature of your application. And, for example, I've done a lot of event sourcing in the past, and you get similar, not only are you getting the event source, but you're getting all the projections too. And oh my gosh, there's data everywhere.
Yeah,
right.
It's going to be so expensive.
There's patterns, right. But there's even patterns, that I've done in event sourcing where you basically, the idea is you have a stream for every aggregate, and let's be honest, the best aggregates are always sagas. They're not just data stores. They're actually managing state of some kind between steps in a process. But once you've done that, you can actually, instead of hydrating it from an entire stream of events, you can snapshot it. And in fact, you can even forward one stream to another and say, you're going to go here from now on, and you can have a pointer to the previous stream, and the next stream starts with, right after that, the latest snapshot. And then it's events. So you can have a snapshotting event in the event stream. And then that way, anything that has similar to fact modeling, right? Anything that doesn't have a prior, you can actually consider archiving. Maybe you don't archive it by default, but you look at how old it is. When's the last time the stream was written to? And you might say, any stream that hasn't been written to in 6 months, we're going to put in cold storage, right? We're going to move it to Glacier or whatever you want to do on Amazon or Microsoft or whatever. I don't see why you couldn't do the same thing with fact models if that was a requirement for you in your use. Kafka does not do this by default, but Pulsar does. So if you have immutable streams, right? They're topics in Kafka, and I can't remember what they're called in Pulsar. But if you have those, Pulsar will automatically take things after a certain date that you specify and start putting them in cold storage, so you're not paying as much for having them hot loadable. But they're still there, and Pulsar will transparently go back further in history and pull them out of cold storage if somebody hits them.
That's awesome.
Anyway, yeah, so I mean, these kind of things are doable, right? But also don't over-engineer it. Does your use case really require those things? Is, the ultimate question. But yeah. I was going to ask, what about graph databases for a lot of this stuff with pipelines and optimizations? I mean, it seems that there's some pretty strong correlation between what I see when I look at historical modeling and what I think of when I think of a graph database.
Yeah, I must admit that I hadn't actually tried implementing historical modeling on top of a graph database. But what I can say is that if like a relational database, like a document database, a graph database offers you so many other features, and historical modeling is deliberately feature constrained. So yeah, it's possible to get all of the features you need. So I would just say that there's also the possibility that that you might be tempted to go go around the rules of historical modeling and start to query your graph database in a different way.
Yeah, that totally makes sense. I was thinking in terms of if you abstracted that decision away inside your immutable runtime, so that's opaque to the actual consumer. But if perhaps you knew of, but I haven't really used graph databases extensively either.
Mm-hmm.
I was just thinking in terms of that. Oh, we lost John. In terms of the potential optimizations that you might get from something like that, just I mean, the other thing is you can always project your facts into indexes, right? If you want faster querying performance for different reasons, there's nothing stopping you from, generating your own projections that are more efficient for whatever reason you might.
Yeah.
Decide.
Yeah. So yeah, that's really two different ways of using a data store. So for your projection, so it's no longer the system of record, as much as I'm on record for disliking that term, but yeah, so it's not the source of the facts. It's the projections you query through it. I use Elasticsearch for that purpose all the time. I find that it's great for search. It even says so in the tagline. And so yeah, you can update your projections, index them. And then when you do your search, now that gets you to enough information to put together the fact that's now the start of your pipeline, and you can open up your application.
No, that's great. That's great. I like it.
So yeah, I think graph databases would be good for that as well. but yeah, I think more than that, I think graph databases would be good for the underlying fact storage as well. I had tried fact storage in Elasticsearch, and it didn't really work out quite so well. It wasn't as bad as when I tried it in Mongo. That was a bad experiment. Mongo's
really?
Mongo's a great database, but it's just not for that. Because
I can see a key value store not having exactly the things that you might need, but interesting.
Yeah, it was the way that so the types of queries you end up with a factual store is that you're doing the where not exists, and you're doing several steps, successor steps and predecessor steps, and then in order to implement those in Mongo, I used Mongo pipelines. And as it turns out, a Mongo pipeline, once it gets I think past 2 steps, it might even be on the second step, I'm not sure, it starts to turn into database scans effectively, or just scan the whole index. So yeah, it was pretty bad, or maybe it was just the way that I was translating the factual queries into Mongo pipelines, or maybe it was just an early implementation and it's gotten better, but it was just
I don't know. I keep coming back to PostgreSQL because and of course you use that in the book, which I loved, and of course it has amazing JSON capabilities as well. So you could actually use Postgres for both your projection indexing needs and your fact store needs. Probably not in the same database, but you could on the same server. Why not? I mean, you absolutely could do those sorts of things. So that's kind of what I've been actually looking at as well. There's a project that I contributed 2 years ago called Martin, and it turns PostgreSQL into a document store for .NET. And it's amazing. It's way easier, actually, in my opinion, to deal with an entity framework because you're using JSON under the covers. So it doesn't eliminate, but it reduces the impedance mismatch greatly. And that's kind of what I've been eyeing as, using something like that as a projection generation piece. And then, of course, Postgres as a backing model for facts. And by the way, I appreciate what you said before, that you can do all of this without the immutable runtime. So, I'm probably going to bump into that with teams that I'm guiding and mentoring right now, because if they're like, well, we're not going to do this until we have the immutable runtime, then it's never going to get traction with them. Right.
Yeah, and I think that it won't get traction with others if there's just an immutable runtime. Yeah, so
I can see that.
Yeah, I know that there are like you talk to a DBA about using Entity Framework. They're like, no, get that out of my database. And that's because they want to have complete control of optimizing the system. They don't trust the abstraction. And they're not wrong to distrust it.
DBA is not a good day, right?
Yeah. Mm-hmm. So yeah, usually when I have those kind of conversations, I'm like, okay, I'm going to, if it's okay with you, we're having a conversation. I'm just not demanding, but the plan is, I'll have an application database where we use Entity Framework, we use EF migrations. It's just all. This is just part of the application, and then we've got the database that you maintain, which is that's the true system of record, and we're going to be feeding stuff into. And you know what? I'll even make it easy for you. I'm going to turn all of my events into store procedure calls. So we will come up with a convention. This is what the name of the store procedure is going to be, and these are going to be the parameters. So you just write store procedures with those names and those parameters, and then you can transform the data into whatever you want.
Yep.
So usually that conversation goes pretty well.
Yeah.
But
I was being tongue in cheek about not wanting to talk. Mostly.
Yeah. So I did put together a talk for Pluralsight Live coming up next week, which is basically espousing the business value of immutability. It's immutability is a competitive advantage, and that really kind of goes into what the immutable organization ends up looking like. So in that talk, I kind of skipping over all of the hairy details, because this is like an executive level talk, but
right.
But I am saying that if you think about autonomous business units, you've got different groups of people that all have the same goal. It's not like a department where everybody has the same skill set but different goals. But now this is cross-functional but common goal, and so you want to give that business unit autonomy to achieve those goals. They're going to need to create information technology infrastructure and IP in order to do that. So they'll start out with Excel spreadsheets, email, PowerPoint, or SharePoint, and kind of then they'll need to build a custom application. What kind of custom application are they going to build? It's going to be an API, a server, and a database. Just your cloud arrow box arrow cylinder, and so what does success look like in that? Well, first of all, what does failure look like in that scenario? Well, it looks like you've are not able to finish building this infrastructure, and so the business unit fails. It could be that it was just a bad idea in the first place, and that's going to happen. But then, what does success look like? Success looks like this business unit succeeds. We're now running our business based on this information technology, and so all of the data in order to necessary to run this business is in this database, behind this server, behind this API. So success looks like a silo. And now a new autonomous business unit comes along and says, hey, I've got this new product that I want to offer. I want to find all the customers who bought this product, and I want to offer them training. So we're going to kind of piggyback. That means I need my IT to hook up to your IT. So now the successful autonomous business unit has made a decision at some point in the past about what messages they're going to publish, what their API is going to look like, and the new autonomous business unit is sort of constrained by those past decisions. And the successful business unit is not incentivized to update those decisions, and in fact they're disincentivized because they're the successful ones and everybody depends upon them. So success looks like stagnation. So couldn't we flip this around? And that's where I kind of go into comparing it with blockchain and how the data's on the outside. I don't think I referenced Pat Helland's. No, it was after that I discovered Pat Helland's paper, data on the inside versus data on the outside. But yeah, he's talking about data on the outside, things that flow between applications tends to be immutable, and data on the inside tends to be mutable. And there's different reasons for them to have different shapes. And so kind of taking that viewpoint and looking at, well, why does blockchain handle interactions between different parties so well? And that's because it puts the data on the outside. It's not locked in somebody's database. It's not behind somebody's API. You can come and you can participate in the blockchain, and then you can go away. And the data that you left there is still there for others to use. So if we take this idea of instead of a blockchain, we have a graph, but it's still on the outside. Now you've got the decision substrate that I talk about in the immutable organizations, where you have, instead of everybody building their application to their own custom database, now you build your application to store all of your facts in this decision substrate, and others can come along, see those facts, subscribe to them, create their own successors, build on top of them. And so now success looks like sharing this information on the substrate with everybody else to participate in. And success no longer looks like stagnation, it looks like innovation. And failure even doesn't look quite so bad, because when your autonomous business unit fails, it stops producing that data, but the data that it produced in the past is still there. And you can still analyze it. You can still come back and say, hey, wait a minute, there was some nugget here. We can pick up that idea, modify it a little bit, and build on top of what was already left behind. So that's really the ultimate, pie in the sky, lock this guy away, he's gone crazy vision of these immutable decision substrates.
It just makes sense. It just makes sense. In the beginning of Yuval Lowy's book, Writing Software, he says early on what he calls the Zen of Architecture. For most developers, there's many ways to do things, but for the master architect, there's very few, and very often there's only one. And it's, when I read this book, I really was starting to think this really does seem like the right way to do a lot of these things. And even thinking in terms of, you could even build a factual, we've had to do this with event sourcing. How do you build an event source model from an existing static model database, right? An existing relational database model. Well, a lot of times you have to do that for integration purposes. In a similar way, I could see people starting to say, well, these are the rules for how we generate these facts. And they may not even be the best facts. They may not be the most clean facts. They may not be the best factored facts, but they're facts nonetheless. And just because they're not pretty facts doesn't mean we get to pretend they didn't happen, like holocausts and wars. Like, they still happened, right?
Yeah.
So I can see that being another aspect of this as well, as you keep pushing into helping the business adopt, right? Nobody's saying you have to redo everything at once either. You could start getting the benefits of these things by even bolting this onto an existing data structure.
Yeah.
Michael, and what about microservices then?
Yes.
Because you are suggesting one big database with all the facts from all different departments.
Yeah.
Interplanetary file system, like you said.
Yeah, I love that example. So a microservice in this world. So let's take the idea of an immutable runtime and look at it as if it were, hey, maybe there's a Docker container that is just I want to create a new immutable runtime, and then that's my base image, and now my application extends that image. What is in that container? It's the the APIs that it's going to use to talk to the outside world, for the outside world to talk to it, and the data store. So so that means this node is not like a web server that's now talking to a database. It's got its own data store within that node. And so now, hey, Kubernetes, give me 10 instances of these things, and they just pop up. And now, because they're all running inside the same cluster, they know about each other, they discover each other, and they start to synchronize using, well, I hate that word synchronize for reasons I already went into, but they start talking to each other based on these pipelines. They say, well, this is what I'm interested in. Okay, here comes the data, and it starts to get distributed among them. So now a microservice looks like the application that you build with this base image. So it's like, okay, I'm running inside of this container, and now I have immediate access to this node's data, and the application is expressing interest through the pipelines. And then the runtime just makes sure that it shares that data with the outside world. So a database is a data container and a topological idea all in one. So it's a thing that you deploy to a server or a cluster of servers, and that holds your data. So a decision substrate, using the term substrate, I wanted to call to mind that this is not a topological component. It's not a thing that you install and that everybody now comes talk to. You participate in the substrate by becoming part of that network, and now your microservice is running inside this node, gathering the information that it needs to make its decisions, sending those decisions back out to those that are interested in them, and then it can come and go, and the data persists because it's been shared. So yeah, it's one big database in the data term, but not one big database in the topological sense of the word.
No, that makes sense. And the more you get to more of a quote central, like a big node, let's say, maybe and I don't want to call it central, but thinking of it as a network, the more you get to a big node, the more you might need to have different strategies like sharding and partitioning of the data to be able to serve up the the smaller nodes' needs. And as you're talking, I'm even thinking as well about the pipeline rules now can influence your load balancing and routing strategies to the appropriate nodes. And you could say, well, these are the nodes that serve up this pipeline. This one's under heavy load. I'm going to send you to this one instead. And you could build a massively parallel, massively scalable Kubernetes auto scaling, blah, 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 right? That literally just grows into Skynet. I mean, grows into, it's fascinating.
Something like a living organism, this structure.
Yeah, I think I've already gone off the rails with the with what I am proposing. I don't want people to actually think that I'm a threat to humanity.
Yeah, I know. That's why I said Skynet tongue in cheek. But it's already built. Let's be honest. We're just So are we meeting still next week as like a wrap up, or is this the end?
This is the end of the book club. So so next week I'll be at ProSite Lab. So no meeting this time next week. The week after, Jan has proposed that we start just kind of going over Janaga, just a a quick high level overview of what is currently the most successful immutable runtime.
Janaga internals.
Yeah,
sounds cool.
And what I think I would like to turn this into is sort of an open source stand up. So I know that we've got now 2 projects that are still nascent, but so Janaga.net and the Factual Studio. So yeah, I think meet, talk about progress on those or other projects that we bring to the table. So Jeff, you were showing off some of the things that you were doing, like with the internal DSL in C# and that sort of stuff. So yeah, I think this.
Yeah, and
this
I'd love to start collaborating on that stuff. That would be really cool. I think it'd be good to talk about too, like maybe where the open source would end and maybe where the closed source would start. Like I could envision some of this more heavyweight stuff being the sort of things that might be good to keep behind a closed door. And it's like, here's the open source factual modeling, and here's a simple implementation of Postgres. But if you really want to go hog wild, you can get this commercial license for the big metal, big crazy. Just
absolutely.
Just a thought there.
Yeah, and that
sounds great. I'd love to keep digging into this and figuring out how we can collaborate more on this moving forward.
Cool, excellent. Yeah. I think having that business model, establishing that while establishing the open source model, is going to be vital. Because it's going to help adoption, because we'll get the the bigger businesses that are like, I'm not going to just take somebody's open source project, but hey, if you're offering professional services and you've got a subscription model, and like one of the ideas I would this whole Docker container thing, I would love that there's going to be that Docker base image that'll be open source. But I would love for you to also be able to go up to Azure, go up to AWS, and say, I want to subscribe to this service, and now I've got a decision substrate deployed in the cloud, and somebody else is managing it for me.
And it's auto scaling, and it's auto sharding, and it's auto routing, and it's auto load balancing, and that's where you'd be like, you're paying for that. You're paying lots for that.
It's auto invoiced.
Yeah. Hey, real quick before I run, I just wanted to share one thought I have with you guys. I came up with a new idea for a new cryptocurrency. It's called CrackCoin. And the proof of work on CrackCoin is your ability to crack a cipher. So someone gives you a public key, and you determine the prime numbers that are used to generate the private public key pair, and they post a bounty. And if you do it and you show the proof of work, then you earn the bounty, you get the coins, and then you build up this whole network that's making encryption stronger by incentivizing people to find ways to break encryption. Anyway, I don't know, maybe it's a crazy idea, but it sounds like a fun, not bounties for breaking into systems, not bounties, just it's bounties for breaking some cryptographic key. Yeah. Right.
Yeah, this isn't the public key for the Amazon certificate. It's not that. This is.
And if it was, you'd have to find a way to either police that or just, yeah. And by the way, then Amazon had sure as heck better figure out how to, fix that problem, right? Rotate your keys or whatever. Yeah. Anyway, give that some thought.
Yeah. In fact, kind of going down this tangent a little bit. I'm certainly on the record for being anti blockchain, but this is one of the things that I think blockchain is one of the social benefits that it's providing us, is that it is a huge honeypot for crypto weaknesses. So if somebody finds an attack against elliptic curve, then there's a whole bunch of ECC public keys out there for them to start cracking.
Well, and the idea with the bounties is now you have a market in this stuff, so you can actually start to do some predictive metrics on what's likely to be cracked sooner than others, right? And people could maybe add to the bounty and this sort of a thing. And then on the other side of it, just like there's a have I been pwned, like it'll tell you if your email or your password even has been part of a hack, this would be the same thing. Has my key been cracked, right?
Yeah.
It's my $1 billion idea. All right.
I love it.
I gotta go.
All right. And you share it with us.
Yeah, that's right. Go build it. See you guys.
Awesome. See ya. So yeah. No meeting next week, but I'll post
2 weeks.
Yeah, I'll post something about 2 weeks, and we'll get things going.
Okay.
But yeah, thank you so much for being part of this. I'm really looking forward to what we build together.
Thank you for sharing with us, because without the book, I think we were never able to understand anything of it. I've been going through it so long, and if I see now what the book added to it, a query or an inverse query without the theory behind from the source code, you will never get it.
Yeah.
So this was really necessary. Thank you for that.
Awesome.
Thank you,
You're
Michael.
welcome. Yeah, thanks. All right,
Okay.
see you all later.
See you. Bye-bye.
Bye.